Hello everyone, in this video we are going to see about the microprocessor architecture. Let us see block by block. This is the whole diagram of the architecture of microprocessor 8085. So let's give a glance of all the blocks over here. So here we have accumulator, which is the one of the register by which the calculations are done intermediately, and there are temporary registers, 8 registers are there, and we have many flags. These flags helps to indicate some presence of and absence of some bits, and this is the ALU to do all the arithmetic logical operation, and instruction register carries all the instruction from the program one by one. The currently executed instruction will be stored in the instruction register, then it will be executed by the computer. And then firstly see the blocks, and then we see about this flow. And then this is the set of registers. All the registers we are having WZ, they are temporary registers, and then BC, DE and HL, and there are other registers like stack pointer, program counter, increment, decrement, address latch. Actually these registers helps in fetching the data to do the operations, and we can also combine this BC as a individual, as a single unit to access 16 bits, and here D and E individually it is 8, and combinedly we can use as a 16-bit register. Likewise H and L also, and stack pointer is a special register which helps to contain the data in the stack mode. That is, we can use the data which is needed for some recursion technique or some other expression, postfix evaluation. We have seen so many applications of these stacks, and these stacks have a pointer to indicate the top of the stack, which is a stack pointer. Program counter is the register where all the instructions are first stored in the program counter, then it will be executed. So whichever the program counter points is the instruction which is taken and executed by the instruction decoder. Okay, and then here we are having different buses: address buffer, data or address buffer. So this buffer helps to hold the data in between. For example, if you are adding a large value, if you want to store the carry, otherwise if you are having some other data which we need to store for some time, so those things will be stored in the buffer. And as buffer the intermediate registers, they are smaller in size, and this array of registers, collection of registers, is the register array, and this is the register select. Okay, this line will help to find out which register is used. For example, if we say the equation is A is equal to B plus C, and then B and C has the data. Okay, now this register select will select the B and the C register. Likewise, this select is the control signal to select the registers. Okay, so these are about the register block. And then these have buses, address bus and data buses are there. We know that bus is the control line carrying data from one portion of the microprocessor to the other portion. So you are having address lines A0 to A7. It is AD because it is both address and data. There can be used as either address or data depending upon the selection bit. Okay, but in the case of A8 to A15, the higher address, they are all only the address buses. Okay, and then that's all about this register area. And then we have the multiplexer. This multiplexer selects the register from the registers available. Okay, and then we are having this part is called as a timing and the control. This timing and the control helps to activate the system or pass the message, and how to control the flow of the system, working of the system. All things is done in the timing and control system. So here we are having clock, and a general clock is there, a clock generator is there, and then this will create an output called clock out. Okay, and this ready is the signal to say the system is ready. That is an input signal for the system. And then we are having the control signals read and write, which is enabled when we are reading or writing the data. And then AL is the arithmetic latch, address latch enable. So this will help to enable the latch of the address. That means if you want to make the data bus as address bus or data bus. According to the AL is enabled, it will be address bus or data bus. And then we have two status signals, S0 and S1, to know the status of the system. And then we have IO and memory. This is the IO or memory. That means the input and can be written or read from IO or memory. That means the data can be stored in the memory area or it is in the IO device. Okay. So accordingly the access can be done. So we are using this signal IO/M, which says whether the input is from input output device or from the memory area itself. And then next to two lines, hold and HLDA, this is mainly concerned with the DMA. What is DMA is direct memory access. Okay, this is one of the method to helps in the fast access of data. So it is called direct memory access. For this we have two signals, hold and hold acknowledgement. And then reset, we have reset in and reset out. We know that when system is not working, we again reset the system. So that is done by this reset in and reset out. Okay, so that's all this timing and control section. And then we have two things, the power supply and the ground. Power supply is plus 5 volts and the ground. Okay, and coming to this top portion, here we are having the interrupt control, we are having interrupt signal, interrupt acknowledgement. So the signal is inward and acknowledgement is outward. And then we have other reset interrupt signals like reset 5.5, 6.5 and 7.5 and the trap. So these reset flags have different applications. We'll see in the next classes in detail. And then finally we have the SID and the SOD, which is the serial input output control, how the data comes in and comes out of the processor. So okay, that's all the components of this microprocessor. And then you can see the flow is from, this is the internal bus, this is the 8-bit internal bus, it carries the data, and from the bus we are just the buses carries the data between the internal bus and the buffers. And then all these dark lines shows the flow of the control, how the data comes in and how the data goes out. Okay, so the arrows and interrupt is either way, both bidirectional, and this control is bidirectional, and some signals are unidirectional based upon the necessity whether it has to read or write. That means that the operation is done in either one direction or both the directions. Okay, so let us see part by part. Yeah, let us see what is a register. There are nothing but they are the flip-flops. We know that flip-flop is a single thing which stores the data either in the on or off. Okay, so flip-flop is on means if the value stored is 1, flip-flop is off means the value is 0. So these helps to store the data basically. So they are called flip-flops, contains zeros and ones, which is a single bit storage. And the registers are many types, general purpose registers. These general purpose registers are 6 in number, that helps to get the data inside and process the data and store the output also. Okay, and they are named as B, C, D, E, H and L. We have seen in the previous block diagram. They are general purpose registers, and these registers are combined as B, C, D, E and HL to execute the 16-bit operation. Individually B and C everything is 8, and when they combine B and C it is 16. Likewise we can combine D, E and HL. Okay, and then these are all the programmable registers. What is programmable register means? Programmer can use the register for programming. That is called programmable registers. That means these registers are accessed by the programmer to insert and transfer the data by making use of these registers by the instructions. And temporary registers, these registers are used by the ALU to store the data on temporary basis, and these are not accessed by the program. That means the programmer cannot write the program using the temporary registers. They cannot use the registers W or Z temporary registers to write in the program. They can use only B, C, D, E, H and L. Okay, in the program. So this is the part which we have already seen in the first slide. This is all about the data and the address. The part is shown. So we are having different, these are temporary registers, there are general purpose registers, special registers. So these registers are selected by the register select line, and then when the register is selected, the data is passed to and from the data bus, and this address buffer and the data and address buffer are the intermediate storage to hold the address or data for some time when it is taken from the concerned buses. Okay, and the communication is also between the internal bus as well as the address buffer, and here data bus and address buffer are communicated, and the lines are from AD7 to AD0, which is the lines 0 to 7, 8 in numbers, and this is 8 to 15. This is the again 8 lines, which is A8 to A15. So the low order values used is as both address as well as data, whereas the high order bits are used only for the address buses. So again, let us see some more thing. Program counter, this is basically a special purpose register that is used to store the memory location of the instruction to be performed. So we know that program is a set of instructions. One instruction is executed at a time. So whichever the instruction is currently executed is passed to the program counter. That means the program counter is incremented once the instruction is executed. And then stack pointer is a special register, the 16-bit register. It is also a part of the memory. The data is stored in the stack in the serial format, and the stack pointer generally stores the address of the last data element stored in the stack. That means stack is the last in first out data structure. So we keep on pushing the address inside the stack, and the last pushed item can be taken out first. That is the idea of last in first out structure. Then accumulator is an 8-bit register that stores the result of the operations performed by the ALU. So we know that ALU does the operation and the intermediate values are stored in the accumulator. And then we will see about the flags. So flags are basically the status of the current result generated by the ALU and not the result. That means the presence of the flag means it is a 1 and the absence means 0. For example, a carry comes after addition, so the carry flag is on. Likewise, the flag indicates some signal. That is the concept of flag. We have different flags in the system. 8085 is the microprocessor what we are seeing now. They have 5 flags, and the 5 flags are carry flag, sign flag, zero flag, parity flag, and auxiliary carry flag. So what is carry flag? The carry that comes out of addition or that borrow that helps in the subtraction, and sign flag is the one which helps to indicate the sign of the data, positive or negative. So positive by 0 and negative by 1, and then zero flag is the flag that helps to indicate whether the 0 is reached or not. This is used when we are using the counter. When we start the countdown, we start from the highest number and we repeat the operation till the 0 is reached. That time we are using the 0 flag, whether to say the 0 is achieved or not. And then parity flag, this is the important flag which helps in the checking of the data. So this parity has real meaning in the system to check whether the passed data, that is, it is mainly used in the communication of information, and whether the data passed is right or wrong is judged by the parity flag. And finally, the auxiliary carry flag. Suppose we are using 2 bytes, and in between 1 byte we get a carry. That is, carry is called as an auxiliary carry flag. Okay, so normally used flags are sign, carry, and 0. Okay, so now again the diagram I'm just presenting here. It is all about the scene we have seen so far. So generally, to summarize, we are having registers, set of registers. For the registers, data is selected using the address bus and the data bus, and the instruction is held in the instruction register. This is done by the decoder, and these decoders execute the instruction and pass it to the timing and control circuit. So accordingly, the data will be read or written using all these informations with the whether it is read or write, or from where to write, where to write to where to write, where to read. So all these things are done by this timing and control unit, and this is all about the ALU, which does the arithmetic operation, which uses all the flags, temporary registers as well as the accumulator, and this is the interrupt control that helps to handle the abnormal situation in the system, and this is the input and the output of the system. Okay, so that's all the architecture of microprocessor. The applications of microprocessors are, they are used in programmable calculators as well as in the numerical control and the environment monitoring system. So when you are monitoring the system, we can monitor the temperature or the pressure, any measurement can be done, and those can be controlled by the monitoring system. In those systems they are using the microprocessor. And we have seen in the traffic signal, we have seen the traffic lights, the traffic signal lights, they are all done by the microprocessor, and they are also used in the switching, banking and the financial system. So we can see in the bank, the caller system is there, and in the financial system, teller system is there. So all the system microprocessor play an important role. So that's all the concept of the architecture of how the microprocessor is built. Hope it is easy to follow, and thanks for